Okay, so today we're going to be dealing with this three-phase circuit. Now, it's important to note that although this is a three-phase circuit, it's not a balanced one. As we can see, the voltages are all balanced, and it's also important to note that this is going to be a positive sequence because B is 120 degrees off from A rather than a positive 120 degrees. So, since it is in this configuration YY, the line current is going to be equal to the phase current. So calculating for each of these currents will be as simple as dividing these voltages by these loads. Now, as for the values of the loads, I did go ahead and just turn them into magnitude and angle form. That way we won't have to deal with too many conversions. But this can be thought of as a different circuit, for example. So if we wanted to find current IA, we can do so by simply so this is going to be our node N. This is our first load, and this is going to be VA. So from this circuit, it's pretty intuitive to see that IA is going to equal VA divided by Z1. So in practice, what that'll give us is that'll give us 2.12 with a phase of negative 32 degrees. And this will, of course, be in amps. And we can just follow this logic for all of the circuits. So if we have a load, say Z2, and some voltage VB, in order to find this current IB, we can still just follow Ohm's law and take the total voltage and divide by the resistance. So VB divided by Z2 So this will give us a current of 5.54 with a phase shift of negative 176 degrees. And this is, of course, in amps. And then for IC, we will simply just follow the same rules that we've been following so far. So we're just going to use Ohm's law, which is going to be the voltage at C divided by the resistance. Well, in this case, the load. So this is going to give us a current of 2.56 with a phase shift of 159 degrees. And this will all be in amps.